Dear students, hope you are all well. So students, in the last class, we learnt about what is air pressure, altitude of the region and air pressure, and air temperature and air pressure, and horizontal distribution of air pressure. Today we will learn what are temperature zones and pressure belts, that an equatorial low pressure belt, mid latitudinal high pressure belts, subpolar low pressure belts, polar high pressure belts, and effects of air pressure and isobars. First, let us discuss what are temperature zones and pressure belts. Okay, as we all know that equator divides the earth into two equal halves. In figure 4.2a, we can see the different temperature zones. The nearest to the equator is the torrid zone. You can see in the figure 4.2a. The nearest to the equator is torrid zone. Then comes temperate zone and the last is frigid zone. The temperature zones are equal for both the poles. In figure 4.2b, we can see pressure belts, which are influenced by the uneven distribution of temperature. The uneven distribution of temperature also leads to the formation of low and high pressure. As you can see in figure 4.2b, there are low and high pressure belts horizontally between the equator and the poles. Now, there are 7 pressure belts. Equatorial low pressure belt is the first, which is in between the equator. Then comes the mid-latitudinal high pressure belt, which are on both the sides of the equator. Then subpolar low pressure belt. This is also, you will find it on both the sides of the equator. And polar high pressure belt. This is also found in both the sides of the equator. The extent of an air pressure belt is up to 10 degrees parallel, which is narrower compared to the latitudinal extent of the temperature zones. You can see that all these pressure belts are 10 degrees parallel. For example, the temperate zone, can you see the figure 4.2a now? For example, the temperate zone extends from 23 degrees 30 minutes to 66 degree 30 minutes. Let us now discuss the following questions. Okay, given in your textbook related to temperate zones and pressure belts. First is, which pressure belt is mainly found in the tropics? Now, in the tropic regions are near to the equator, and so the temperature in this region are high. And as we know, when the temperature is high, the air pressure is low. And so, you will find the equatorial low pressure belts are found in the tropics. Next question. With which pressure belts are the polar winds associated? In which temperature zone are they observed? So the polar winds are associated with polar high pressure belts and subpolar low pressure belts. It is observed in the frigid zone, right? You'll find it in the frigid zone. Next question. What could be the reason behind a low pressure belt in the tropics? So, as we discussed earlier, low pressure is formed in the tropics because the temperature is high. Next question. With which pressure belts are the winds in the temperate zone associated? So, the winds in the temperate zone are associated with mid-latitudinal high pressure belt. You can see the temperate zone. What is there with the mid-latitudinal high pressure belt? Next question. Write the latitudinal extent of the low pressure belts. So the latitudinal extent only of the low pressure belt, okay? The latitudinal extent of the low pressure belts goes from 50 degrees north to 50 degrees south. So equatorial low pressure belt it is, right? And 55 degree north to 65 degree north as well as south. That is the subpolar low pressure belt. Let us move forward. Now students, let us now discuss the different pressure belts. Okay. First is equatorial low pressure belt. This low pressure belt extends from 0 degree to 5 degree north and south of the equator. It's at both the sides. Due to the perpendicular sun rays between the Tropic of Cancer and Tropic of Capricorn, the temperature is high in this region. So in the equatorial low pressure belt, you'll find the temperature high because it's close to the equator. Air in this region gets heated, expands, becomes lighter and move towards the sky. As this process operates continuously, a low pressure belt gets formed in the central part of this region. Why central part? Because it is the equatorial low pressure belt and it is found on the equator. Next is mid-latitudinal high pressure belts. It extends from, where will you find the mid-latitudinal high pressure belt? It extends from, you can see the arrows in the figure. It extends from 25 degrees to 35 degrees north and 25 degrees to 35 degrees south of the equator, both the sides, north and south. The warm air which rises from the equator cools down, as a result of which decreases. Due to low temperatures at the higher altitudes, the air becomes heavier, right? When it goes up, it becomes heavier. This leads to the formation of high pressure belts in both the hemispheres. This air is dry. In this region the air is dry. Hence the region does not get rainfall. So most of the hot deserts on the earth are found in this region. You'll find all the hot deserts in this region. That is the mid-latitudinal high pressure belt. Next is subpolar low pressure belts. Warm currents from tropical and subtropical areas carry lots of heat to this area and develops high temperature and low pressure conditions. Due to rotation of the earth, winds get deflected in other directions, which leads to the development of low pressure belt. This condition, now where will you find this? This condition is observed in the area between 55 degrees and 65 degree parallels in both the hemisphere. That is the subpolar low pressure belt. Let's move forward. The last one is polar high pressure belts. In both the polar regions, the temperature is below 0 degree Celsius throughout the year. So here the air is cold. As a result, high pressure belt gets formed. Now as you know, polar regions is cold. So the temperature over there is mostly in 0 degree Celsius or minus throughout the year. These are called polar high pressure belts. They generally occur the area between 80 degrees and 90 degrees parallels in both the hemispheres. Okay, let's move forward. The next is effects of air pressure. Air pressure is one of the important characteristics of the Earth's atmosphere, which regulates the wind and weather pattern across the world. Let us look at the effects one by one. First is origin of winds. Now, wind is the flow of gases on a large scale on the surface of the earth. Wind consists of the bulk movement of the air. Wind means when lots of wind is blowing, bulk movement of the air with full force. The wind is caused by differences in the atmospheric pressure. Next is the generation of storms. A storm is any disturbed state of a body, especially affecting its surface, and a stormy implying a wind force. Storm is not, the wind is very strong at that time. A storm can cause significant destruction and lightning, heavy precipitation, heavy rainfall, strong winds, dust storm or sandstorm, etc. That's generation of storms. Next is convectional type of rain. Convectional rainfall occurs when the energy of the sun heats the surface of the earth. How do you get rainfall? When the surface of the earth is heated, causing water to evaporate to form water vapor. When the land heats up, it warms the air, right? When the land heats, it warms the air above it. This causes the air to expand. That means the air expands and it starts rise up. As the air rises, it cools and condenses. This process of condensation forms cloud. We had seen this in the water cycle. So it expands, it cools and it condenses. So this process of condensation form clouds high in the atmosphere, high in the sky. If this process continues, that means if this process continues, what do we get? We get rainfall occurs. So convectional rainfall is very common in areas where the ground is heated. For that, the ground has to be heated, then it expands and then it moves higher, then it forms water vapor, that is it forms clouds, and then we get rainfall, right? By the so where it is formed, where the ground is heated by the hot sun, such as in the tropical areas, right? We see in the tropics, that is the tropical area, that is in the equatorial low pressure. Okay, let's move forward. Next is isobars. Now, isobars are lines on a weather map. As you can see in the figure, isobars are lines on a weather map, joining together places of equal atmospheric pressure. That means these lines join together equal atmospheric pressure, means with the same number. Okay. These are basically used to explain and understand various weather phenomena. It's used for the weather. The weather determined by the movement of the wind. The wind direction is ultimately dependent upon the atmospheric pressure. The numbers measure the atmospheric pressure in millibars. So these numbers are measured in millibars. The closer the isobars, now these lines are called as isobars, right? So the closer the isobars are together, the windier it is. That means if the lines are more closer, it is more cool at that place. Now let us now take a look at figure 4.3 from your textbook and discuss some points given below. First is the nature of the isobars. Now, as you can see in the figure, the isobars here are those blue lines, okay? As you can see in the figure, the isobars are mostly moving from the west to the east. You can see the lines are mostly moving from west to the east. Second is high and low pressures, belts and their latitudinal positions. So first is which pressure belt comes? First is equatorial low pressure belt. And where it is located? It is located on the equator. You can see over there, right? Then is subpolar low pressure belt. So first we will look at low pressure belts. Okay, then we will see high pressure belt. Then comes the subpolar low pressure belt, and it lies in the subpolar zone. Okay, now next is we'll look at high pressure belts. Next is mid-latitudinal high pressure belt. And where it lies? It lies above the equator. Can you see, right? It lies above the equator. Means it lies above equatorial low pressure belt. Okay? And then comes polar high pressure belt. And it lies near the subpolar zone. Where it lies? To the high, right? Polar high pressure belts you will find towards the heights. Next is the direction of the isobars and the distance between successive isobars over oceans and continents. Now, mostly over the oceans. You can see there are oceans and there are continents in the map, right? Mostly over the ocean, the isobars are parallel. Okay, they're parallel to each other. And over the continents, they are somewhat uneven. That means where the oceans are, mostly you can see the isobars are parallel. As you can see where the equatorial low pressure belt, you see where the oceans are there, they are parallel. And where the continents are there, they are uneven, like they are in curved shape, right? Next is comparison of the isobars in the northern and the southern hemispheres. Now, in the northern hemisphere, you can see the isobars are far spaced and uneven. That means there is space between the isobars in the northern hemispheres and uneven. Whereas in the southern hemisphere, it is closely spaced and parallel. In the northern hemisphere, the isobars are far spaced and uneven. That means it's like together, congested. Whereas in the southern hemisphere, it is closely spaced and parallel. You can see downwards how the isobars are. There is enough space between them. But in the northern hemisphere, they are a bit congested and they are in curved shape. Let's move forward. That is your homework. Pressure belts are formed between the dash and the dash poles. Next is the line that joins the place of equal pressure on the map is called a dash. The next is state the effects of air pressure. And the last question is what's an isobar? That's all for now. Your chapter ends over here. We will learn the next chapter in the next video. Thank you for listening, children. Goodbye. Take care.